Here is a fixed length of fence, enough for a perimeter of 20 meters, and the plan is a rectangular pen. Here are two ways to use it: a long, thin strip, 9 by 1, or a square, 5 by 5. Same fence for both. Which one holds more room inside? It is very tempting to think that since the fence is the same length, the room inside must be the same too. But look hard at the thin strip. It is almost all edge and hardly any middle at all. The shape matters, and it matters a lot. So rather than argue about it, let us list every option and settle it for good. A perimeter of 20 means the four sides add to 20. A rectangle has two lengths and two widths, so one length plus one width is exactly 10. That little fact is the key to everything. Every pen we can possibly build has its length and width adding to 10. So there are only a few, and we can just list them all. Because the sides add to 10, the whole number pens are 9 by 1, 8 by 2, 7 by 3, 6 by 4, and 5 by 5. 5 pens, drawn to scale, each using the very same fence. See how the thin one on the left is barely there, and each one to the right grows plumper and fuller, closer to a square. Now count the room inside each. 9, 16, 21, 24, 25. The areas climb steadily as the pen stops being long and thin and grows toward a square. And the clear winner is the square, 5 by 5, holding 25. Compare that with the thin 9 by 1 strip, which held only 9, from the exact same length of fence. Nearly 3 times the room, just by choosing a better shape. Fat beats thin every single time. And this is not a fluke of the number 20. A long, thin rectangle spends almost all its fence on length and gets barely any width, so it stays nearly empty. The most room comes from balancing the two sides. Balance the two sides perfectly and you get a square. And that is where the area peaks. So here is the general truth the little list quietly revealed. For any fixed perimeter at all, the square encloses the greatest area of every possible rectangle. One example and a rule for all cases. So when a question asks which is best, and the options are few, do not guess or argue. List every case in order and lay them side by side. This is called enumeration, and it is completely reliable. Very often the list does more than answer the one question. As you watch the numbers march, a pattern jumps out. Hear that the square is always fattest, and you walk away with a general truth for free. Your turn, a fence of perimeter 24 this time. Which whole number rectangle holds the most room? You know the trick now. Pause and find it. Perimeter 24 means length plus width is 12. You could list them all again, but the rule already tells you the answer. The squarest whole number pen is 6 by 6, and its area is 36. The square wins again, exactly as the pattern promised. That is the rule paying you back. One more, as a head-to-head. A perimeter of 16. Which holds more, a 7 by 1 strip or a 4 by 4 square? Both use the same fence. Pause and decide. 7 by 1 holds just 7. 4 by 4 holds 16, more than double, from the exact same length of fence. The thin strip wastes its perimeter on edge. The square turns it into room. This is why boxes, pens, and rooms are built fat, not long and thin. The squarer the shape, the more it holds for the same edge. Push the idea past rectangles, and the roundest shape of all, the circle, beats every polygon. It is why bubbles are round. And that whole chain of ideas started from nothing more than patiently listing 5 little pens in order. So when the shape seems not to matter, list the cases and look. For a fixed perimeter, the area climbs to the square, and the square holds the most. Enumeration answered the question and handed you a rule along the way. That's all for this video.